In part A of the lab, we're going to use a DigiMelt instead of the apparatus shown in your lab manual. A DigiMelt is more accurate than the traditional thermometer, so there isn't really a need to calibrate it. Plus, you can also control the rate of heating, also called the ramp rate. So we're just going to make sure that the DigiMelt is plugged in, and then there are some quick start instructions off to the side, and I'll go through those in a bit. But we're also going to turn the DigiMelt around, turn it on, and now we'll go on to the next part. You might be wondering, how are we going to put a sample into the DigiMelt? We're going to use a melting point capillary. So there's an open end and then a closed end. And then we'll place the capillary into our DigiMelt once we've placed a sample into the capillary. And I'll show you how to put a sample in there in a second. Now we can watch as our sample melts through the viewfinder. There's also 2 other spots, so we could have a total of 3 samples in the DigiMelt at once. Off to the right, there are 3 buttons: start temp, ramp rate, and stop temp, as well as some buttons with arrows on them. So if we hit start temp, we can set the starting temperature of the DigiMelt. So this is helpful if we know the melting point approximately. We can start a little below it, and we can adjust the start temperature using the arrow keys. Next is the ramp rate. This is the rate of heating. So right now it's set at 2 degrees Celsius per minute. So that means that every minute the temperature will increase 2 degrees Celsius. And then finally, we're going to set the stop temperature. And right now it's set at 250 degrees Celsius. But we can change that using the arrow keys as well. Finally, we're going to hit the start-stop button on the far right. And this is going to allow us to start preheating our sample. And then eventually, when it's ready, we can put our capillary into the device, and we'll press start again, and then we'll watch it melt. First though, we should probably set up our samples. So for part A, we're going to use 3 different compounds that all look very similar. The first one is benzophenone. The second one is benzhydryl. And the third one is vanillin, which is found in vanilla beans. So we're just going to place a little bit of each into the weigh boats in front. To add sample to each weigh boat, I'm going to use a small spatula shown here. We really only need a small amount of each sample. So let's start with benzophenone. And you can see that benzophenone is a white powdery solid. And again, we're just going to scoop a tiny bit into our weigh boat. Next, we're going to clean the spatula so that we don't cross-contaminate our containers. So I'm just going off screen and wiping off the spatula. Next, we're going to add a little bit of benzhydryl to the middle weigh boat. You can see that this is also a white powdery solid. So normally, if you didn't know which sample was which, it would be really hard to distinguish between these 3. But using melting points, we can figure out which one is which. Now here you can really see that some of the solid is stuck to the spatula, so I'm going to wipe it off again before I move on to vanillin. All right, all clean. So now we're going to add a little bit of vanillin to the whey boat on the far right. Again, vanillin is a white powdery solid, so it would be hard to determine which sample is which. And again, we can use melting points to help us with that determination. Of course, in this first part, we already know which sample belongs to which container, so we don't really need to guess here. Now, in the next step, we're going to grab 3 capillaries. And again, each one has an open end and then a closed end. All right, so now we're going to grab the first capillary and we're going to place a little bit of benzophenone in it. So I'm taking the open end of the capillary and I'm going to tap it into the sample. All right, so we really only need that much sample in our capillary tube. It's a very, very small amount. Now we need that sample to go to the bottom of the capillary in the closed end. So what I'm going to do is tap the capillary on the countertop gently, and the solid should fall to the bottom. Now I'm going to do the same thing with our other 2 samples, benzhydrol and vanillin. Now we're ready to put our samples into the DigiMelt, but first we want to try to pick a range of temperatures that encompasses all of our samples. So we already know what the melting points of our samples are. So what we're going to do is pick a starting temperature that's below the lowest temperature. So let's just do 30 degrees Celsius. We'll also leave the ramp rate at 2 degrees Celsius per minute, and then the stop temperature, we'll set that to 100 degrees Celsius. So this should encompass all of our melting points for each sample. Now we're going to wait for the DigiMelt to preheat, and once it's ready, we'll see a green light next to the word ready. The green light has shown up next to the word ready, so that means we can put our samples into the slots at the top. I'm going to put our benzophenone sample on the far left. So there's benzophenone. And then I'm going to place benzhydrol in the middle. There's benzhydrol. And finally, I'm going to place our last sample, vanillin, into the slot on the far right. That way we're keeping the same order that we saw before. Now that we're ready to start, I'm going to hit the Start button, and I'm going to focus on benzophenone and benzhydrol first, because their melting points are 48.5 degrees Celsius and 69 degrees Celsius respectively. So now we're melting, or rather heating, the samples, and I'm just going to fast forward the video and slow it down at the points where the samples are melting. So at this point, I'm starting to notice a change in the benzophenone solid. It's starting to get to its melting point. So what we're going to do is just keep a close eye on benzophenone. And when you notice a liquid form, that's when we're going to record our melting point. Now, we might have to record a melting point range if, for instance, we see a drop of liquid, but there's still solid present. And then we'll record the starting point and then the ending point. All right, it looks like it's about to form. Oh, yep, there's a liquid forming there. You can see a meniscus at the bottom. So we're going to record that temperature we see on the DigiMelt. And it looks like it melted very quickly. So we could just write 49.1 or whichever temperature you think closely matches the melting. Now I'm going to shift our perspective here so that we're focused on benzhydrol, and we're expecting a melting point of about 69 degrees Celsius. So I'll fast forward the video again until we see it starting to melt. So I'm starting to notice a change in the solid for benzhydrol again. And we're just going to record the starting point where we see a liquid form and then the ending point when everything has melted. Or if you notice just one temperature at which everything melts, we'll just record that. So here we see a liquid form. There's still a little bit of solid, so maybe we'll write down a melting point range. And feel free to rewind if you want to focus on the temperature a little bit more. Now we're going to focus on our last sample, vanillin. And I'm going to fast forward until we notice the solid changing. We're expecting a melting point of around 83 degrees Celsius. Again, I'm starting to notice a change in the solid for vanillin. So we're going to keep an eye on the solid and mark down the temperature at which it melts. And again, if there's a range of temperatures, you can write that down too. Okay, so let's see, we're almost there. And it looks like we started to form a liquid. We're starting to see a meniscus form on the bottom. So we'll write down that temperature that we see on the right. And again, if you feel that there's a range, you can write down the range. So now we're going to hit the Start Stop button. And in this case, we're stopping the process. And now the DigiMelt is going to cool down. In part B of the lab, we're going to mix one of our samples with a contaminant. Now, in this case, we'll know what the contaminant is. So we're starting with benzhydrol, which we already measured the melting point. And I'm just going to use my sample from before because there's a little bit left in my weighboat. Our contaminant will be palmitic acid. So typically when a sample has a contaminant in it, the melting point is lower than expected, and we end up with a wide melting point range. So we're just going to mix in some palmitic acid into our benzhydrol, and we'll measure the melting point and see the difference between our pure benzhydrol sample and our mixed sample. So I'm just adding a little bit of palmitic acid to the weigh boat, and then I'll mix it around and we'll set up our melting point capillary. So I already set up the DigiMelt, and now we're going to place our sample into the middle just so we can keep an eye on it. And I'm just going to refocus the camera onto our sample, and now I'm going to hit start, and the heat is going to increase. So I'll fast forward the video to the point where we see the sample starting to melt. So I'm starting to see a slight difference in the solid, and it looks like it's about to melt. So let's just keep an eye on the temperature, and we'll record the point at which it starts to melt. Here you can start to see the solid breaking down. And what's happening is the heat is giving enough energy to break apart intermolecular forces between molecules. So now I can see a meniscus forming. So I'm going to mark down that temperature. And there's still some solid melting here, so this is more of a melting point range. So we'll just wait until everything has melted, and then we'll mark the end of the melting point range. So remember, our benzhydrol sample that was pure had a higher melting point, and it all melted fairly quickly. But now that it has a contaminant in it, the melting point is lower, and we have a melting point range. It's taking a much longer amount of time to melt everything. So this is something to keep in mind when you're analyzing samples. Are they pure or are they impure? Do they have a distinct melting point, or is it a melting point range that's below what we expect? In part C, we're going to record the melting point for an unknown sample. So I've already acquired the unknown sample, and I'm just going to set up our melting point capillary. So I've already set up the DigiMelt with the start and stop temperatures, and it's ready to go. So I'm going to place our unknown sample in the middle again and just focus in on it. And then we're going to press start, and it's going to start heating. So again, I'm going to fast forward the video until the solid starts to look like it's melting. So the solid is starting to change. So I'm just going to wait until we see that meniscus at the bottom, which indicates that a liquid has formed. And then we'll record the temperature. Okay, so it looks like we've got a liquid forming there. So let's record the temperature, and we'll just wait for it to finish melting. Now, if you do have a pure sample, the melting point range would be about a degree or two. But if you have an impure compound, then the melting point range would be really wide, beyond 2 degrees Celsius. So this looks like a pure compound to me. So does this temperature match any of our samples from before? Let's do some tests to find out. So in this part, I'm going to mix my unknown with 3 known compounds that have similar melting points. So benzhydryl has a similar melting point of 69 degrees Celsius. Palmitic acid has a melting point of 62.9 degrees Celsius. And then I also chose benzophenone, which has a melting point of 48.5 degrees Celsius, although that's a bit of a stretch. That's quite a bit lower than our unknown, but we'll run the test anyway just to see what happens. So the idea here is if we mix our unknown with compounds of similar melting points, this will help us rule out if the known compound is a quote-unquote impurity, or if the known compound matches our compound. So I'm just going to prep all of the capillary tubes, and then we'll test the melting points. So I've already prepped the DigiMelt, and we've got our different samples here. So in the first slot, I'm placing the unknown mixed with benzhydryl. In the middle, we'll place our capillary with the unknown mixed with palmitic acid. And then in the last slot, we're going to place our unknown mixed with benzophenone. And I put a little too much in that one, so we'll see what happens. Okay, so now I'm going to focus on the last 2 capillaries because I kind of expect the unknown mixed with benzophenone to melt pretty quickly. But we'll focus in. Oh, yep, you can see the unknown mixed with benzophenone has melted very quickly. So that's our 3rd capillary, the one on the far right. So we know right away that that can't be our sample, right? Our unknown is not benzophenone because it melted at a much lower temperature. than our unknown. So now I'm just going to focus on the first two capillary tubes. The one on the left is our unknown mixed with benzhydryl, and the middle is our unknown mixed with palmitic acid. And we're just going to record the temperatures at which these mixtures melt. Our first capillary is starting to show some changes. So it looks like it's about to melt. And remember, our first capillary on the left was our unknown mixed with benzhydryl. Now, we do know that the melting point of our unknown was higher than this temperature shown here. So this tells me that our unknown probably isn't benzhydryl, because this capillary is acting like an impure compound. So let's just keep an eye on the temperature and let's record the melting point of our mixture. So this has taken quite a while to melt, which also tells me that this is not a pure sample. So our unknown cannot be benzhydryl. But we'll just record that ending point there, 60.1, for the melting point range. And now let's focus on our middle capillary. And remember, this capillary was our unknown mixed with palmitic acid. And it looks like it is starting to change a little bit, so let's just keep an eye on it until it melts. Okay, I'm starting to see some liquid forming on the bottom there. So let's record that temperature. And this is really close to the temperature of our unknown. Additionally, this sample is melting really quickly, which tells me it's a pure compound, not a mixture. And this brings me to the conclusion that our unknown must be palmitic acid. So make sure to write down the melting point, and then you'll be able to complete your post-lab assignment.